Dear students, today I'll discuss with you some important MCQ from the chapter solution. So these problems are based on and these questions are based on Henry's law and Raoult's law. The first question, the mole fraction of a gas dissolved in a solvent is given by Henry's law. If the Henry's law constant for a gas in water at 298 Kelvin is 5.55 torr in multiplied 10 to the power 7 torr and the partial pressure of the gas is 200 torr, then what is the amount of gas dissolved in 1 kg of water? And these are the choices given. Okay, so we'll do according to Henry's law. You see, P a partial pressure of A Henry's constant multiplied XA. XA is the mole fraction of A. Okay, so XA is equal to, you will get PA by Henry's constant. Okay, so your PA is given 200 and Henry's constant 5.55 multiplied 10 to the power 7. Okay, so XA is, we know mole fraction is equal to Na by Na plus NH2O. Okay, so your Na for very dilute Na, you take NH2, means you can neglect this one. Okay, so your Na mole fraction of A, so mole fraction of this one is how much mole? This is your 1000 by 18, that is Na by 55 point something else you will get. Okay, so you can take this Na is equal to XA multiplied 1000 by 18. Okay, because Na is equal to XA multiplied 1000 by 18. So this is XA, that is you get this one 3.6 multiplied 10 to the power minus 6 multiplied 1000 by 18. So you will get 0.2 multiplied 10 to the power minus 3, which is equal to 2 multiplied 10 to the power 4 mole. What is the question? What is the amount of the gas dissolved in 1 kg? Okay, so your answer is A, 2 multiplied 10 to the minus 4 mole. Okay, you understand? You see. Next, question number 2. The solubility of a gas in water at 300 Kelvin under pressure of 100 atmospheric pressure is 4 multiplied 10 to the minus 3 kg per liter. Therefore, the mass of the gas in kg dissolved is 200 ml of water under pressure of 250 atmosphere at 300 Kelvin is what? And these are the choices given. So what to do? By Henry's law. Okay, this is your KH partial pressure. Okay, KH is the Henry's constant. Okay, so for different gases, so you will take what is soluble of gas in water, partial pressure atmosphere, ethic this much. Therefore, the mass of the gas in kg dissolved in 250 ml. So, for two different pressures at constant temperature, at two different pressures, you will take what? M by M dash is equal to P by P dash. Okay, so M is given 4 multiplied 10 to the power minus 3 divided m dash we do not know, and this is 100 torr and this is 250 torr. One is 100 torr given, one is 100 torr, another is 250 atmosphere, it is given. Okay, so m dash is equal to, you will get how much? 10 to the power minus 2 kg per liter. Okay, but for it is asked for 250 ml. Okay, it is asked for 250 ml. So for 250 ml you will get what? 10 to the power minus 2 by 4. Okay, so you will get how much? 2.5 multiplied 10 to the power 3. Okay, so this is for kg per liter, but for asked 250 ml, so you have to divide this one by 4 and you will get this one. Okay, so the choice D is the, choice A is the correct answer. Okay, choice A is the correct answer. Next, the amount of solute molar mass 60 grams per liter that must be added to 180 gram of water so that the vapor pressure of water is lowered by 10%. Okay, so how to do this one? To take P0 is 100 mm and PS after adding solute, PS is decreased by 10. 100 minus 10 is equal to 90 mm. This is your pure solvent and this is the solution. Okay, lowered by 10%. Okay, so according to Raoult's law, P0 minus PS by P0 is equal to W2 by M2 multiplied M1 by W1. Okay, so your 100 minus 90 by 100 is equal to W2 by W1 M2 60 multiplied 18 and 180. Okay, so you will get W2 by solving this, you will get it is 60. So the answer is B, 60 gram. Okay, next question. At 80 degree centigrade, the vapor pressure of pure liquid A is 520 mm of mercury and that of pure liquid B is 1000 mm of mercury. A mixture solution of A and B boils at 80 degree centigrade and 1 atmosphere pressure, then amount of A in the mixture is how much? So these are the choices given. So we'll do partial pressure. So the total pressure P total at 80 degree centigrade is 760 mm, but P total is equal to mole fraction of A and partial pressure of A plus XB mole fraction of B partial pressure of B. Okay, but we know XA P0A is equal to, so XB we can write because XA plus XB is equal to 1, that is mole fraction. Okay, so instead of XB we can put 1 minus XA multiplied P0B. Okay, so P0B we can write P0B. Okay, P0B plus you take these two and taking common XA, and you will get PA0 minus PB0. Okay, so this is partial plus 2, total partials is 760, and this is your P0B 1000, and this is 520. This is 520 minus P0B 1000. Okay, and XA is, you have to calculate XA. Okay, so XA, you see, XA, you will get how much here? XA is equal to 240 by 480. Okay, therefore XA is equal to 0.5. So the answer is 50 mole percent. Okay, so this is 50%. Next question. Two liquids X and Y form an ideal solution. The mixture has a vapor pressure of 400 mm and at 300 Kelvin. When mixed in the molar ratio of 1:1 and vapor pressure of 350 and a vapor pressure of 350 nm, when mixed in the molar ratio of 1:2 at the same temperature, the vapor pressure of the two pure liquids X and Y respective are this. So these are the choices given. You see how we will do this. Molar ratio 1:1 means what? XA is to XB, that is, or you can write XA is equal to XB is equal to 0.5, because molar means these two, when XA plus XB you have to get 1. Okay, therefore this is 0.5 and this is also 0.5. Okay, so P total is equal to X OXX PX0 plus XY PY0. Okay, so here you can write XY XY or XX plus XY. Okay, yes. So P total is given 400. So XA, this is 0.5 and PX0 plus 0.5 PY0. Okay, so you will get how much? PX0 plus PY0 is 400 divided 0.5, that is you will get 800. Okay, when molar ratio, see this is 1, when molar ratio is 1:2, that means what? Molar ratio is 1:2. So what you will do? You see, when molar ratio is 1:2, it is X is 1/3 and Y is 2/3. Okay, because whenever you add these two, you have to get 1. Okay, so it's 1:2 means this much. So when this is 1:2, then what is the formula? The total pressure 350 is 1/3 PX0 plus 2/3 PY0. Okay, so 350 is equal to 350 PX0 plus 2 PY0, and you have to multiply this 3. So this is these three will come here. Okay, so you will get how much? 1050. So px0 plus 2 py0. So this is one equation, px0 plus py0, it is 800, and this is another equation, px0 plus 2 py0 is 1050. Therefore px0 is your 500, 550, and py0 is your 250. Okay. Next question. So choice, which one is the correct answer? The 5. E is the correct answer. This comes in the Kerala medical examination. This question comes in Kerala medical examination. 5 choices are given. 1, 2, 3, 4, 5 choices are given. Okay, next. Two liquids X and Y form an ideal solution at 300 Kelvin. Vapor pressure of the solution containing 1 mole of X and 3 mole of Y is 550 mm of Hg. At the same temperature, if 1 mole of Y is further added to the solution, vapor pressure of the solution increases by 10 mm Hg. Vapor pressure of X and Y in their pure states will be respectively what? Okay, so we'll do the next question. See, X in the ratio 2 liquids X and for ideal solution containing 1 mole of X and 3 mole of Y. Okay, so you take X is equal to 0.25 and XY is equal to 0.75. Okay, it is 1 and this is 3. Okay, so P total is equal to XX px0 plus xy py0. Okay, so total is 550, and you will get here x 0.25 multiplied px0 plus 0.75 py0. Okay, so you take common 0.25, take common. Okay, so this is your px0 plus 3 py0 and 550 divided 0.25. so you will get, by dividing this, you will get what? You will get 2200. so this is one equation. So by adding, after adding 1 mole of Y, after adding 1 mole of Y, what will happen? It is what? 1 mole and 3 mole, 4 ratio you are getting. After adding again Y, it will be 5. So after adding Y, it will be 5. So what will happen? The ratio x is equal to 0.20 and xy is equal to 0.80. You understand now? You see, after adding Y, it brings 5 times. So xx 0.20 and xy is 0.80. Okay, so 560, total pressure 560 is 0.2 xx plus 0.8 xy. Okay, so you take 0.2 common, so 560 by 0.2 and x plus 4 xy. This is another, so you will get here how much? It is 2800. so this is another equation. So by solving these two equations, you will get what? Partial pressure 1 is x you will get 400 and xy you will get the 600. So choice C is the correct answer. Okay. Next, if x1 and x2 represents the mole fraction of a component A in the vapor phase and liquid mixture respectively, and PA0, PB0 represents vapor pressure of pure A and pure B, then total vapor pressure of the liquid mixture is what? Okay, so you know mole fraction phase in the vapor phase, mole fraction in the vapor phase x1 is equal to PA partial pressure by P total pressure. Okay, but PA is equal to, okay, but PA is equal to, so what? PXA multiplied PA0. Okay, so these are all, this comes from the Raoult's law. So hence x1 is equal to x2 PA0 by P total. So P total is equal to PA0 x2 by x1. Okay. Okay students, so out of the choices B is the correct answer, because PA0 x2 by x1, it is the correct answer. Okay, have a good day.